Hello and welcome to SST Chemistry channel. I thought of having a video on Sommerfeld modification of Bohr's atomic theory, otherwise called Bohr-Sommerfeld modification. In fact, when quantum mechanics, the wave mechanics came into being, in the 20s, 1920s, 30s, 40s, then the classical Bohr's theory, which involves classical quantum theory, not quantum mechanics or wave mechanics. At that time, nobody knew that electron can behave as a wave until Schrödinger, de Broglie, Heisenberg, they propounded the mechanics concept in the quantum theory. It's called quantum mechanics or wave mechanics. So when wave mechanics came into being, it explained all unexplained aspects of atomic theory, including the splitting of spectral lines into finer lines, the Zeeman effect, the Stark effect, and other effects. But I thought of discussing this Sommerfeld modification, which to my mind is obsolete. But looking to its historical significance, how at the time of Bohr, that is 1913 to 16, in that period when Bohr was not able to explain why a single line in the hydrogen spectrum was decomposed into multiple lines, 3 lines, 5 lines, multiple lines in the presence of external magnetic or electric field. That is Zeeman effect and Stark effect respectively, as you know. And I'm sure who will be watching this video must have a sound knowledge in Bohr's theory, as well as Bohr's theory at least. No knowledge of quantum mechanics is required. If you have already known quantum mechanical model of atom, Schrödinger's wave equation in terms of psi square and all that, it is well and good to correlate how at those times, 1915-16, at those times, Sommerfeld wanted, in fact he did a bit of modification in the Bohr's theory to explain the splitting of spectral line. Right? Let's proceed. Now, let me read out. You just also follow me reading, and at times I will also explain it. It is an extension of Bohr's atomic theory. It is also called Bohr-Sommerfeld model of atom, and sometimes as a relativistic atomic model. A relativistic atomic model. Why? I'll tell you later why it is relativistic. Sommerfeld proposed that the electron revolves in elliptical orbits. Bohr proposed circular orbits, but he thought that electrons are revolving around the nucleus in elliptical orbits, where the nucleus is situated at one of the foci. There are 2 foci, plural is foci, and at one focus of the ellipse, nucleus is situated, right? Since circle is a special case of ellipse, electrons can also revolve in circular orbits. So, there are circular orbits as well as elliptical orbits, both. To explain the fine structure in Zeeman and Stark effects, Sommerfeld suggested the presence of subcells and suborbits in each principal energy level. Because this SPDF concept, they were not there at that time. But he proposed, yes, each cell is composed of some sub-levels, sub-energy levels or subcells. That idea first was given by Sommerfeld. For a given principal quantum number, only principal quantum number was known in the Bohr's atomic theory. Not L, M, they were not known. Azimuthal and magnetic, those things were not known. Those are the outcome of Schrodinger's wave equation. That the quantum mechanical model of atom, right? So he introduced a new quantum number. Of course, he called it azimuthal quantum number or angular quantum number. I'll tell you. For a given principal quantum number n, accepting n is equal to 1, that is the first cell, there are both circular as well as elliptical orbits, which become non-degenerate in the presence of magnetic or external magnetic or electric field. As long as there is no external field, these subcells, sublevels are degenerate. That means they have same energy. But in presence of the magnetic field or electric field, they decompose into different sub-energy levels, varying in their energy values. Right? The nucleus is situated in one of the foci of the ellipse. There are two quantum numbers. One is designated as nr and the other one is n phi, which take integral values. 1, 2, 3, 4, 5, including 0. nr is the radial quantum number. I'll tell you what is that. You forget about, you presume that you do not have any idea about quantum mechanical model. That L is equal to 0, 1, 2, 3, 4, M is equal to plus minus L, 0 to plus minus L. You forget, you do not know anything about quantum mechanics, for example. So there are two quantum numbers. One is radial quantum number, nr, and the other one is the angular or azimuthal quantum number, n phi. And the principal quantum number which you know and which Bohr knew, he suggested only one quantum number, that is n, that is equal to the sum of these two quantum numbers. The radial and angular sum is the principal quantum number, right? N is the principal quantum number, and that is always 1, 2, 3, 4, 5. 1 for the K cell, 2 for the L cell, I'm talking of capital L, and 3 for the M cell, and so on. And n phi, this is the angular quantum number, will take values from 1, not 0. 1, 2, 3, 4, 5. That was not wave mechanical aspects. It is completely classical approach followed by Sommerfeld to modify Bohr's theory, just to modify. He was a physicist. Physicists are more mathematicians than anything else. So I'll tell you how he modified the equation. And the radial quantum number can take 0 value, 0, 1, 2, 3, 4, right? So the sum of these two is nothing but the principal quantum number that you know. Now see, this is an elliptical orbit and the nucleus is situated at one of the foci. This is one focus. There is another focus here. Supposing the nucleus is here and the electron is moving clockwise at this point. This is the tangential velocity. The tangent at this point, that will represent a velocity vector that is called the tangential velocity. If that vector, tangential velocity vector, is resolved into two perpendicular components, one, let me tell you first that there is a radial vector, a radial coordinate, this is called radius vector, that this nucleus and the point where electron is moving at a particular instant, that line is called the radius vector r, and the angle that the radius vector makes with the principal axis. I'm sure you have the knowledge that an ellipse has two axes. The bigger one is the principal axis the smaller one is the minor axis. So, and the half of it is called the length of the semi-major axis, and the half of this is called, this is A, the length of the semi-major axis, and this is B, the length of the semi-minor axis. And the phi is the angle that the principal axis makes with the radius vector. What is radius vector? The point where electron is moving at a particular point and particular instant, and the nucleus, this line in the direction of the electron, that is the direction of the radius vector, and this is the tangential velocity vector, that is the tangent drawn at that particular point where the electron is moving at any instant. So if this vector is resolved into two components, one in the direction of radius vector here, one component, and another component which is perpendicular to this component. This component is the component along the direction of the radius vector, and this is called the transverse. This is the radial velocity. This velocity component of this main, the actual tangential velocity, the component along the radius vector is called the radial velocity, and the other component in the perpendicular direction is called the transverse velocity, which is in the direction perpendicular to the radial vector. This radial vector and this, they are perpendicular. This radial component, the radial velocity, and the transverse velocity. This is transverse velocity, this is the radial velocity. These are the two components of the main original tangential velocity of the electron. And the tangential velocity is resolved into two components, as I have already mentioned: radial velocity along the radial vector direction, radius vector direction. This is, I have already told, the radius vector direction, and the transverse velocity, which is perpendicular to the radius vector. And hence electron has two momenta. Plural of momentum is momenta, both of which are quantized. Quantum theory is applicable. You know, one of the postulates of Bohr's theory, that the electron's angular momentum is quantized, takes certain permitted values which are integral multiples of h by 2 pi. Same thing here, but there are two momenta. One is the radial velocity, radial momentum, and transverse velocity. This is the transverse velocity, this one. This is the radial velocity. These are the two components of the main tangential velocity. So corresponding to the transverse velocity, this is the momentum is not called transverse momentum, it is called the angular momentum or the azimuthal momentum. So there are two momenta, one due to radial velocity vector, here this one, and the other one due to the transverse velocity vector, this one, that is called the angular momentum or azimuthal momentum, right? The angular momentum, which you were saying before, without splitting this main vector into two components, you are saying simply MVR is equal to NH by 2 pi. Now we have two equations. M V, this, supposing this we call the component is VR, that is equal to N into H by 2 pi, and the angular momentum, this is supposing this transverse vector is, let us call it Vt transverse. So MVTR is equal to NH by 2 pi. So this N are related to the transverse vector, that is transverse velocity, therefore the symbol phi. So, but these are integral values, 1, 2, 3, 4, like that. So both the momenta are quantized, because this is quantum theory, not quantum mechanics. there is a huge difference between quantum theory and quantum mechanics, where quantum mechanics takes electron as a wave. So there is a wave equation, it is Schrodinger's wave equation, right? Now see, now the calculation I have not shown here. Here, the derivation I have deliberately excluded from this lecture. This is not a physics program where I am supposed to give you the details of the mathematical derivations that have been used for this final expression B by A. This B by A, the semi-minor axis by semi-major axis, is nothing but equal to n phi. N phi is what? There are two quantum numbers I have told you. One what is called the angular quantum number or azimuthal quantum number n phi. The other one is radial quantum number, that is nr. So, but the sum of nr and n phi is equal to n. N is the principal quantum number. So it was derived, it was found that B by A, this B by A is nothing but equal to the the angular quantum number, azimuthal quantum number, by the total principal quantum number, that is n phi by nr plus n phi. Nr is the radial quantum number, n phi is the angular or azimuthal quantum number. This radial quantum number is due to the radial momentum, this radius vector, radius vector and the radial velocity. This is radial velocity, and the n phi, the angular momentum, angular quantum number, is due to this transverse or angular velocity. The transverse velocity, that is called transverse velocity. That's not called angular velocity, that is called transverse velocity. But the momentum is called angular momentum or azimuthal momentum, and the quantum number is called angular quantum number or azimuthal quantum number. But this vector is called transverse vector. So these two vectors, they give two different momenta and therefore two different quantum numbers, nr and n phi. The sum is equal to, the resultant of these two vectors is the main vector. Similarly, the sum, the arithmetic sum of the two quantum numbers, nr and n phi, will give you n, the principal quantum number of the cell. Now I am showing you here, supposing this is the first cell, it is only having one subcell. So when n is equal to 1, the number of subcell is equal to 1, represented by n phi is equal to also 1. And in that case, nr will be equal to 0. For a given value of n, the n phi can assume n different values starting from 1, not 0, 1, 2, 3, 4 up to n. And the total number of values is n. So there are n number of subcells for any given cell. Out of the n number of subcell, one is circular, the rest are elliptical, right? For example, the first cell, n phi is equal to 1, and since the principal quantum number is equal to n is equal to 1, so nr is bound to be 0. So when n phi and n, they are same, so this ratio is 1, then b is equal to a. When principal axis is equal to the major axis is equal to minor axis, and that is nothing but a circle. Circle, as you know, is a special case of ellipse. So the K cell, the first cell, has only one suborbit subcell, and that is the subcell itself. The first cell has only one subcell, that is itself, and that is circular, that is not elliptical. Because n phi cannot be 0, because if it is 0, then B is equal to 0. Then the electron will move in a linear manner passing through the nucleus. That means it will collapse with the nucleus, which is not possible. Therefore, his logic was n phi cannot be equal to 0. Later, after 1926, when Schrödinger gave the equation, he derived the quantum numbers starting from 0, the azimuthal quantum number starting from 0. But in the time 1916, 15, 16, when Sommerfeld tried to modify Bohr's model to explain for this fine structure of hydrogen spectrum, he gave n phi, the azimuthal quantum number, as starting from 1, not 0. It can never be 0. But it can be 1, 2, 3, 4, 5 onwards. So, the second cell, now see second cell, has one circular and one elliptical. The third cell has two elliptical. These are the two elliptical and one circular. So, here in this diagram, you have three cells. First, second, third. First cell has only one suborbit subcell, that is circular, where n phi is equal to 1. Since n is equal to 1, so nr is equal to 0. So when n phi and n, they are 1, 1 each, then this ratio is 1. So B is equal to A. So it is a circle. But in second cell, there are two n phi values. I told you the number of n phi values, as per his assumption, will be the number of the principal quantum number value. If n is equal to 2, so there are two n phi values starting from again 1 and 2. Two values, 1 is one value, 2 is another value. The number of values is 2, right? So for when n phi is equal to 1, nr will be equal to also 1. So it is 1 by 2. So semi-major axis is 1 and minor axis is 1, major axis is 2. So it is bound to be an ellipse. But the other case, when n phi is equal to 2, nr will be equal to 0. So that the principal quantum number is 2. So 2 by 2, 1. So when n phi is equal to 2 for the second cell, it will be a circular orbit. Similarly, for the third cell, there will be 3 n phi values, 1, 2, 3. For 1, it is 1 by 3 is ellipse. For n phi is equal to 2, 2 by 3, again ellipse. But when n phi is equal to 3, 3 by 3 at that time, nr is equal to 0, so it is circular orbit, right? So same thing I have written here, just let me read out. When n is equal to 1, that is k cell, n phi has only one value, and that is 1. That is 1, not 0. And in that case, nr, the radial quantum number, the radial quantum number is 0. Radial quantum number has come from radial momentum, and that has in turn come from the radius, the radial vector. I mean this radial velocity, this velocity. The component of the main vector, tangential vector, along the direction of the radius. This is the radius vector. This is the radial velocity. This is the transverse velocity. The radial velocity corresponding to that is radial momentum. It can be 0 also. And corresponding to, radial momentum and radial quantum number. So the radial velocity has two things. One, radial momentum and radial quantum number. That can be 0. That can be 0. And can be quantum number. Can be 0, 1, 2, 3. But n phi, the azimuthal quantum number, which is the result of this one, transverse component of the tangential vector, which has a momentum called the angular momentum or the azimuthal momentum, and the corresponding quantum number is n phi, the azimuthal quantum number or angular quantum number, not transverse quantum number. Got it? Now I have written same thing. When n is equal to 1, n phi is equal to 1, and nr is equal to 0, the sum total will be equal to 1, because n is equal to 1. Sum of these two must be equal to 1, and hence B by A is equal to 1, and hence it is circular. When n is equal to 2, there are two n phi values. N phi is equal to 1. In that case, nr will be equal to 1. 1 plus 1, 2. And it is elliptical because n phi by n, which is equal to B by A, n phi is equal to 1 and n is equal to 2. So 1 by 2 means it is an ellipse. But when n phi is equal to 2, nr will be equal to 0. So in that case, B by A is equal to 1. 2, n phi is equal to 2 and n is equal to also 2. So 2 by 2, 1. So B is equal to A, it is circular. So second cell has one elliptical orbit and one circular orbit. Similarly, third cell has three n phi values. N phi is equal to 1, in that case nr is equal to 2. N phi is equal to 2, where nr is equal to 1, because the sum will be equal to 3. And hence there are two elliptical orbits. One, the B by A is 1 by 3 when n phi is equal to 1. The other one is 2 by 3 when n phi is equal to 2. And the third one is n phi is equal to 3 when nr is equal to 0. So that is a circular orbit because B by A is equal to 1. Because you know n phi by n is equal to B by A. B by A is equal to 1 means it is a circular orbit. Similarly, when n is equal to 4, the fourth cell has 4 azimuthal quantum numbers. 1, 2, 3, they represent the elliptical orbits, and 4 represent the circular orbits. In the same way, the B by A is 1 by 4 when n phi is equal to 1, 2 by 4 or 1 by 2 when n phi is equal to 2, and 3 by 4 when n phi is equal to 3, and these three are elliptical orbits. When n phi is equal to 4, it is B by A is equal to 1, it is circular orbits. Right? I have shown it once again for you. You know, I made this video just to have an idea about the historical significance of this modification. Initially, I thought not to have any video on Sommerfeld model or Bohr-Sommerfeld modification. But it excited me to that extent because the relativistic theory, I'll tell you just after a bit, what is relativistic theory? The modification that he introduced in the Bohr's calculation to get another equation for energy. I'll tell you that. So in the literature, not literature, in the textbooks that you find in the Indian or elsewhere, I think elsewhere also, you will find the presentation has been done in a manner which has something not very much there in the original paper by Sommerfeld. So listen to me, you'll read the other books, you'll find what is the difference there and what I am telling you. But in other other literature, you find the same what I am saying. But in some other text, you will be finding in place of n phi, you will find a term k, n by k. N is the principal axis, n is the principal axis, k and the major axis, and k is the minor axis. K term is there in place of n phi. So forget about it, same thing. So I have represented the 4 cells in 4 places. This is the first cell here. This is not theta, this is phi. I have copy pasted all these diagrams from the internet source, so that is why it looks like theta. N phi is equal to 2, n is equal to 2 circular, n phi is equal to 1, n is equal to 2, it is elliptical. So similarly, third cell, n phi is equal to 3 circular, and 2, 1, they are elliptical. So less is the B by A ratio, it will look more and more, thin. The minor axis will go on decreasing. Similarly, the fourth cell has 3 elliptical orbits, and I have copy pasted where k was written in place of n phi. I have corrected it according to my presentation. The azimuthal quantum number here, originally given by Sommerfeld, was n phi. N is the sum of n phi and nr. N is same for all the 4 orbits and 4 suborbits. but phi values are changing. This is phi is equal to 4, this is phi is equal to 3, this is phi is equal to, as the phi value will go on decreasing from the highest value, which is equal to n value, I mean the n value, as the n phi value goes on decreasing, you know, it will start in the circle, will go on becoming dwarfer and dwarfer in thickness, becoming elliptical, and it will be spreading, and it will be dwarfer and dwarfer because the minor axis will be decreasing, right? So this is the dwarfest, but in all these cases, the focus of foci is the place where the nucleus is situated, right? And circle, the center of the circle is the same as the focus of all these three elliptical orbits, representing three suborbits. This is one suborbit, a circular suborbit, and these are the three elliptical suborbits. But remember that these carry equal energy as long as there is no external field. The moment you have external magnetic or electric field, then what he believed, then they decompose into different energy levels. They are now no longer degenerate suborbits. I'm not talking about degenerate orbitals. You forget about orbitals now. Degenerate suborbitals, I mean subcells, right? So they will be non-degenerate only when there is a magnetic or electric field, right? And we are almost at the end of our program. The energy equation that you know for hydrogen and hydrogen-like species is E is equal to minus K. K is a constant. Z square by N square. Same constant. That K same. This is SI. Same. This is mass of the electron. This is Z, atomic number of hydrogen or hydrogen-like species. For example, helium plus, Z is equal to 2, Li double plus, and Z is equal to 3. And E is the charge of the electron, which you know, 1.602 10 to the minus 19 coulomb. And E is the permittivity of the medium that you know. And H is the Planck's constant. And this value, you know, 2.18 into 10 to the power minus 18 joule per atom. That you know, right? Now here the only difference was, while he derived using mathematics, he derived this equation, he found that this, in place of n square, it is nr plus n phi whole square. Is it not the same as n? So if this n, the derivation I am not showing here, the intricacies of derivation you can get it from a source, physics source, but this is same as circular orbits. Nr plus n phi, this sum will be equal to n. That means it is nothing but n. So all the different suborbits that about which we discussed, they will have the same energy. So how to find different energy values for different suborbits when there is an external magnetic field or electric field? And there the contribution of Sommerfeld came. Sommerfeld's contribution was from here now onwards. He used the relativistic effect. This is called the Sommerfeld made a relativistic correction for different energy sublevels. This happens only in presence of external field. Now this is the Hughes equation he derived. Same constant is same, but only extra term is alpha. I'll tell you what is alpha. Alpha square is another term, but all other terms are there in the K. So this is nothing but K, the constant K that you know, 2.18 into 10 minus 18 joule into alpha square. I will tell you what is alpha. Alpha is another constant. And here is the variable term n by n phi minus 3 by 4 into 1 by n to the power 4. This n is fixed for a given cell. Supposing for a given cell n is equal to 2, this is 2 here, this is 2 here. But n phi are different. When phi is equal to 1, and if you put 1 here and 2 here, you get one value of energy, and if you put 2 here, you get another value. So the suborbits now have 2 different energy values. Therefore, there will be, which was referring to 1 transition energy, it will refer to 2 transition energies. I'll tell you, don't worry. So here also I have avoided the long mathematical derivation of this equation. I have deliberately avoided, but you can have it in a physics source in the internet. You can get it if you are so interested, right? So this alpha, the new term here, and this expression, this alpha is called the fine structure constant. That was the proposal of Sommerfeld. Sommerfeld's contribution is alpha, the fine structure constant. That is nothing but E, the charge of the electron square, by 2 into, once again, the permittivity of the medium, C is the velocity of light, and H is the Planck's constant. And it is approximately equal to 1 by 137, 1 by 137. And its square value is used here, right? The relativistic theory of atom is based on the assumption that the electron travels with different velocities at different points in the ellipse. The velocity becomes maximum when the electron comes closer and closer, and when it is at the nearest point to the nucleus. At that point, the energy of the velocity of the electron is maximum because of maximum attraction. And when it goes further away from the nucleus, its velocity goes on decreasing. And at the furthest point, furthest from the nucleus, its velocity is minimum, right? So whenever there is a change in velocity, same electron, same principal quantum number, but different velocities. Supposing this is the focus where the nucleus is situated, and the electron is here, and the next moment electron is here, so farther away, so its velocity changing. And these velocities are no small velocities. They are comparable with the velocity of light. This C is there. It's comparable with the velocity of light. So at that point, now there will be change in the relativistic mass. There is a mass energy correlation, and when you possibly know what equation you use to find the relativistic mass when a body is in motion, and particularly when its velocity is comparable with the velocity of light, at that time its relativistic mass increases, and therefore the relativistic mass of electron varies from point to point. Just like the phi, the angle phi and the radius vector goes on changing as the electron traverses the entire elliptical path, phi and the r vector changes only when it is a circular track, circular path or orbit. In that case, the r vector remains constant, but phi changes. Every passing moment, phi changes, right? So a new concept he introduced, that the mass also changes. Since velocity changes, the mass, this mass is not the true mass, it's the relativistic mass, changes, decreases, increases, decreases, increases. And interestingly, he proposed that electron is not only revolving in an elliptical orbit, the elliptical orbit itself is precessing. Have you seen a top that children play in the ground? The top they use in a thread, and they wind it and throw it to the ground, and it swirls. And when you find a top is rotating about its own axis and also swirling about a vertical axis, that swirling motion is called precession. And if you know what is precession, I need not have to elaborate on that. That precession happens. Now see, this is the motion of electron in one elliptical orbit. But the ellipse itself is rotating. The ellipse itself is rotating. The plane of the ellipse, that itself is slowly rotating about the nucleus. Slowly rotating. Now see, it was here. Supposing nucleus is here. So around the nucleus, this ellipse now will become this ellipse. After some time, it will be this ellipse. So this kind of motion is called the Rosette motion of electron. So he proposed that not only it is rotating in an elliptical orbit along with circular orbit, but that elliptical orbit is undergoing a precessional motion. That is called the Rosette motion. And he used this relativistic concept in the calculation of this. This derivation is based on this relativistic mass effect and the Rosette motion concept. Everything taken together. We will not go to the details about it. In fact, I cannot tell you that because I am not a man of physics who can enter into the intricate aspects, mathematical aspects of Rosette motion and how he used this in mathematical derivation and got this equation. Yes, if you can see it in any source, you can understand, no doubt. But to explain it properly needs a great knowledge of mathematics and physics, which I don't have. So I restrict my limitations to this, the application of this equation to explain how we can, that time when wave mechanics, another 10 years after 1926, Schrodinger's propounded the this wave equation, and then NLM, the quantum numbers, those things came into being. So at the time 1913 to 16, when Bohr was active, at that time Sommerfeld modified the Bohr's energy equation to this. This particularly when there is an external magnetic field, but there is no magnetic field, you can use this equation. There is no different energy values, but when there is a magnetic field, there will be different sublevels. Each sublevel has a different energy values, so you have to use this equation. Right? Now let me explain how at that time he explained the splitting of a single line in the spectrum, say Balmer series. Balmer series, the first line is due to the transition of electron from this third cell to the second cell. Okay, one line, but in the presence of external electric field or magnetic field, they found multiple lines, more than one line, a multiplate. Now, theoretically, there are how many transitions? Since second cell has two subcells, as now we call S and P, 2s and 2p, at that time 2, 1, this is the principal quantum number, 2, the sum of n phi and nr, and this subscript is n phi, the azimuthal quantum number or the angular quantum number 1 and 2. And third cell has 3 subcells. Now we know this is 3s, 3p, 3d, but 3, 1, 3, 2, 3, 3. This is n phi is equal to 1, n phi is equal to 2, n phi is equal to 3. This is n value. So there are 6 transitions. That is from 3, 1 to 2, 2. Then 3, 2 to 2, 1. Then 3, 3 to 2, 2. As well as there are 3, 1 to 2, 1, 3, 2 to 2, 2, and 3, 3 to 2, 1. So altogether there are 6 possibilities. So in the presence of external field, there will be 3 energy levels, sub-energy levels for the third cell, and 2 sub-energy levels for the second cell. So the one which was only unique in transition, there was only one transition because all these 3 was 1. In the absence of external magnetic field, all these 3 are degenerate. So they represent only one level, and these 2 are also degenerate, another level, one level. So from one level to one level, transition gives one line. But now in the presence of external magnetic field, these are decomposed or split into 3 energy levels having different energy values. These 2 energy values. So they are in a different place. They have a lot of gap between them. But the sub-energy levels are close to each other in energy values. But the gap between the principal energy levels differing in the principal quantum numbers, they are large. The gap is large. So there are 6 possible transitions. So it was originally expected that a single line will be splitting into 6 finer lines, what we call a sextate. But really only 3 lines were observed. 3 lines is called a triplet, 4 lines is called a quartet, and 5 lines a quintet, 6 lines is called a sextet. So they were expecting sextet, but actually Stark and G-Man found 3 lines for 1 line. The first line of the Balmer series from 3 to 2 transition, now they found actually 3 lines. Then Sommerfeld thought what to do, what modification now I have to do so that it will match with the experimental finding. Then he proposed a selection rule. Without knowing its logic, he proposed that the transition where the change in the azimuthal quantum number is not equal to plus minus 1 is forbidden transition. For allowed transition, the transition which will result in a detectable intensity and you get a final line will be when delta n phi, the change in the azimuthal quantum number, change delta will be plus 1 or minus 1, not 0, not plus 2, minus 2. They are forbidden transition. He didn't know the logic, just like Bohr did not know why the angular momentum should be quantized. That was proved by de Broglie equation using an electron wave concept, a standing wave concept. You know that. In the same manner, he said no. That also was corroborated in other transitions, the second line, third line, or Lyman series, other lines. That was also corroborated. So he proposed that any transition from any suborbit of the higher principal number to any suborbit of the lower principal quantum number, if delta n phi is equal to plus minus 1, then it is allowed. If it is not equal to plus minus 1, it is 0 or it is plus minus 2 or plus minus 3, it is forbidden, not allowed. So in that case, I have selected only these 3 transitions. So that is, you see, from 1 to 2. Now don't look at the principal quantum number, this n phi, 1 to 2. The change is 1. 1 minus 2 is minus 1, or 2 minus 1 is 1, whatever. Plus 1 or minus 1, doesn't matter. So that is allowed. And from here to here, 2 and this is 1. So 2 to 1, again 1. Then this one, 3 to 2, 1. But which are forbidden? Now see, from 1 to 1, 1 to 1, change is 0. From 2 to 2, change is 0. And from 3 to 1, change is 2, which is also forbidden. So delta n phi is not equal to plus minus 1. These are forbidden transitions. They will result in no detectable intensity. So there will be no detection of any peak, any line, but in which delta n phi is plus minus 1. It is allowed transition, means its intensity is good enough for its observation. So we get only 3 lines due to these transitions and do not see these 3 lines. Therefore, it matched. It tallied with the experimental finding done by Stark and G-Man. But later on in our next program, I will be making a detailed discussion on the G-Man effect. Actual G-Man effect in the light of quantum mechanics, wave mechanics, it's not due to this, it's not only due to the splitting of subcells. It is precisely due to the splitting of the orbitals represented by different magnetic quantum numbers. So at that time he explained the observation by splitting the suborbits, that is subcells of a cell. At that time there was no knowledge that each subcell has several orbitals with different orientations represented by magnetic quantum numbers m. which varies from plus L to minus L via 0, right? And just for your curiosity, let me tell you what we will be doing in our G-Man effect video. In our G-Man effect video, which is similar to Stark effect, the only difference was the Stark effect used electric field, while G-Man used magnetic field. But then we will see that how it was explained. It was not explained in the way that Sommerfeld explained. It will be explained by the splitting of the subcell. Supposing this is 3D, you know L is equal to 2 means D. So this is third cell, D subcell. And it has got 5 orbitals represented by magnetic quantum number -2 to +2. Similarly, 2p has 3p has 3 orbitals px, py, pz and represented by 1, 0, -1, right? So these transitions will be taking place, and these orbitals will be non-degenerate. In the external magnetic field, these orbitals will be also degenerate. Not only this is one principal quantum number, it has got another L is equal to 0, that is S subcell, not shown, and this has another subcell L is equal to 0, another 2 subcells L is equal to 0 and L is equal to 1, that is S and P, not shown. Only I have shown the allowed transition from 3D to 2P, and the other 2 transitions are forbidden transition. Of course, one of them is allowed, but that involves the same energy, transition energy is same, so I have not shown them. So the real splitting of spectral line was explained by wave mechanics by the lifting of degeneracy. I mean, the degenerate orbitals became non-degenerate in the presence of external field. So which was not known. We explained this only on the basis of the decomposition of principal energy levels. But here, this is due to the decomposition of a subcell into orbitals. So there is orbital to orbital transition and subcells and subcell remaining constant. So that is an allowed transition I am taking. And other subcells I am ignoring. One of them is allowed, but I am taking those which will give 3 different energy values. There are 9 transitions which are allowed. So the same delta L at that in the time of Sommerfeld, it was delta n5 plus minus 1. Now in quantum mechanics, del L, same Azimuthal quantum number plus minus 1. Here L starts from 0 in quantum mechanics, and del M, change in magnetic quantum number, will be 0 allowed, plus minus 1 also allowed, plus minus 2 is not allowed. So taking these quantum restrictions called selection rules into account, there is a selection rule for azimuthal quantum number as well as magnetic quantum numbers. So looking to that, there are 9 transitions from 3D to 2P, out of which 3 are different values. Other 6, they fall into these 3. Their gaps, they fall into these 3. So altogether, there are 3 different transition energies. So you get 3 lines. And the other transition which is also allowed, that is when L is equal to 1, 3P to 2S. 2S when L is equal to 0. So that also del is equal to 1. So that is also a allowed transition, and when L is equal to 1, there will be 3, and when L is equal to 0, there will be 1. So there will be 3 more transitions. But their transition energies will be again identical with these 3, one of the 3. So altogether there will be 3 different transitions. So the triplet, the 3 lines, this is the reality that we will be discussing. I am sounding you in advance. The detailed discussion on G-Man splitting or star splitting will be doing later in a separate video. Just correlate between the historical significance of Sommerfeld model, how he derived at that time to justify the splitting. G-Man saw the fine structure during the time of Bohr. It could not be explained properly. And I do say the Sommerfeld model had a lot of defects which could not be explained by the normal classical approach to quantum theory. Quantum theory is okay, is quantized. integral multiple of h by 2 pi. But the wave nature was not taken into account. Right? So with this, we conclude this session. How did you like it? You must, I'll be giving you the link to the PPT file that I have used here in this video lecture as a PDF file for you to refer and study and keep it own and download it and keep it for yourself. And if you have not subscribed to my channel, please do so. It doesn't cost you anything. And if you have really liked this, do not hesitate to put to press on the like button. Bye bye. Take care.